The electromagnetic spectrum is something that learners often struggle with a lot and also struggle to remember exactly in which order we have the various rays that make up the electromagnetic spectrum. So just to give you an idea, we're going to have a look at this part here in the middle, the visible light section first, and then we're going to have a look at how we can easily remember what's to the left of it and what's to the right of it. So I want you to imagine this visible light section here in the middle made of all these various colors, and we are going to use the following abbreviation, Roy G. Biv, to remember these colors. So R obviously stands for red, O for orange, yellow, green, blue, indigo, and violet. So I want you to imagine that visible light is a family, and the family's surname is white. The reason is because when we combine all of these colors, it forms white light. The R here stands for Roy, who is the father in the family, and the V stands for violet. So Roy is the dad, and he works really hard to support this huge family, as you can see, of 1, 2, 3, 4, 5, 6, 7 members. And Roy is actually a little bit tired. So when he walks, he gives these really long steps. Those are his feet. So he actually has a very long wavelength, we can say. Also, Roy's tired, so he has a little bit of energy available, not a lot. So we know that he has a low level of energy, and because his energy is low, we can also say that he has a low frequency. If we move over to the smallest member of the family called Violet, little girl called Violet, she has a lot of energy. So remember, Violet, lots of energy, she's still very young, she has a high frequency as well. And because she has a lot of energy, when she walks, she takes these tiny little steps. So her steps are much smaller. So we can actually say that Violet has shorter steps or a shorter wavelength. And this helps us to remember how we space out the longer wavelength and the shorter wavelength, as well as the higher frequency and the lower frequencies. So let's go and have a look at what happens when we move away from red light. Now, there is light called infrared light. Infra meaning less than. So infrared light will have an even longer wavelength than red light, but an even lower frequency or lower energy. Infrared is actually what makes us experience heat from the sun. Don't know if you've noticed, but on days where we have a cloud cover, we don't feel the sun as much, and the reason is because infrared rays do not have a long enough wavelength or high enough frequency to penetrate the clouds above, which means that the infrared rays are blocked. With an even longer wavelength, we have microwaves. Now, we all think of microwave ovens when we think about microwaves, but microwaves are actually used in cell phones. These rays have an even longer wavelength, lower frequency, and a lower energy. Remember also that infrared light, a good example of infrared light would be ambient heat. So if you are standing next to a stove, for example, and you experience the heat from the stove, or if you stand outside on a sunny day and you feel the sun, you are experiencing infrared rays of light. Infrared rays has a shorter wavelength than microwaves and a higher energy than microwaves. Microwaves used in cell phone reception. So microwaves are therefore a little bit less invasive than infrared light. Then as we continue moving further down, we see we have radio waves, and they are of course used for the transmission of radio stations. These waves have an even longer wavelength, even lower frequency, and a lower energy. If we move to the opposite side of the spectrum, we know we have violet over here. Violet has very, very short wavelength, higher frequency and higher energy than red light and everything to the right on this specific example. But remember that what can be better than violet? And the answer is ultraviolet. Ultraviolet is like violet on sugar. She's like hyped up. she has even higher energy, an even higher frequency, and an even shorter wavelength. Ultraviolet light is the light that is actually coming from the sun, as an example, that can penetrate skin. Ultraviolet light is the light that can cause skin burn. So we know that sunburn comes from ultraviolet light. There are many positive uses of ultraviolet light. Because of its penetrative properties, it's also used in supermarkets to keep food fresh and to kill bacteria. Now, ultraviolet light, on sunny days, we experience ultraviolet and infrared, but on cloudy days, we only experience ultraviolet. So that explains why we can still get sunburned on cloudy days. Ultraviolet light, with its high penetrating ability, can penetrate through clouds and reach the earth and still cause sunburn. Next to ultraviolet, we have X-rays. Now, X-rays are used to scan humans and animals. If we want to have an even more penetrating ray than ultraviolet, we use X-ray. So X-ray, if you've ever taken an X-ray, you know that all that shows up on an X-ray will be bones and teeth. So X-rays have an even shorter wavelength than ultraviolet, an even higher frequency and higher energy, which means it can penetrate more than ultraviolet. That makes sense because I've never heard of someone getting sunburnt on their bones. X-rays, therefore, can penetrate deeper than ultraviolet light. Moving on from X-rays, we have gamma rays. Now, gamma rays have the highest penetrating ability. They have the shortest wavelength, the highest frequency, and the highest energy. They are used in cancer treatment, in radiation therapy, where we want to treat a very specific amount of cells, and radiation therapy will kill those cells. That's how deeply it can penetrate into human tissue. So gamma rays, therefore, very dangerous actually, because if we just have radiation all over our bodies, it can kill all of our cells. So gamma rays are used in medical science as a very specific treatment of a very specific area. I hope this helps in explaining to you how to remember the electromagnetic spectrum. It's a good idea to go and just have a look at especially the wavelength and the frequency and the energy of all these types of light.